increase in Newton's law, what increase? Resistance and force increase. So I added this term. If you look at this one, so resistance due to viscous fluid medium. We already at least I convinced we're filled with this liquid, included the mass was given. So what I did here, so well, you assuming in Einstein's theory of relativity, assuming no resistance, right? So I just separate say, okay, let's take it one step back. Let's assuming mass still the same, using Newton's law, and factor out of the resistance and force. And you see what happens. This is what I got. If you just separate the mass increase, moving mass term, becomes to a separate term as a resistance force. So if you look at this chart is a linear momentum. If you look at the P is a momentum, is basically equals to moving into mass times velocity. So on the left-hand side, in Einstein's equation, moving mass, with this kind of inverse term, that's a singularity term. At the velocity equals 300,000, kilometers per second. It will go to infinity. So what I did, nothing more, just Newton's law. Separate two terms, get the right-hand side solution. I got a smooth translated curve. So this is a Newton's equation, okay, nothing more belongs to nobody else. It's a Newton's relationship. And you see, there's a 97% of a match, entire curve, which means in 100 years ago, over the 100-year period, they made all the observations and testing. They only tested to about as close as 90% of the speed of light. So based on those, or maybe 95% of the speed of light, all the tests. So if that test match Einstein's equation, which is if match this kind of empirical relationship, right? It will match my curve too. This is Newton's curve. It will match too. So basically, however, the beauty is there is no singularities. So why this equation is important? Now we can explain there is one important phenomenon. Have you heard of this called travel speed faster than speed of light? Neutrinos. If you heard of this test, right? Of course, there's a debacle here. Initially, we're talking about, traveling from CERN. I met one gentleman here today. He said he worked there, he liked there, or something. Said that, from CERN, that's Geneva, Switzerland, and shooting a beam underground through the Earth to Italy, Grand Sasso. Initial measurement is 60 seconds, nanoseconds faster than the speed of light. But they were heavily criticized by physicists. They thought that your test must have problems. And so that was started in September 2011. So they did intensely study for almost 6 months to the March 2012. Because initially published by one team in the CERN, in the CERN, but they have 4 teams total. Each have a different laboratory, and they all did all the independent study. And add another one team is from the United States, at Illinois. That's Fermi Labs. They shooting from Illinois all the way to California, San Francisco, or somewhere. The entire world of physics was testing this one. Why are they so keen to them? If anything faster than speed of light, or even at the speed of light, entire modern physics calibration, everything calibrated based on Einstein's equation. E equals mc squared. Calibrated matter, calibrated size, universe, or everything calibrated based on one. So at stake. And you see what happens after 6 months? They said that they found 2 errors. One is a losing cable connected with the GPS, connected, fiber optic cables, losing. Okay, so just tighter a little more. Another they're talking about is the clock. The calculated time clock might be kicking a little bit faster. Okay, after all the scrutiny with the entire world, and then get final results reported, on March 2012. Neutrino particle travel at exact speed of light. What that means? At the exact speed of light, that means a neutrino. The smallest particle is 1 to 10 million size smaller than electron, would have a mass equal to the entire universe, based on Einstein's theory. So you know the problem, right? However, even with this kind of results, the team decimated, criticized, dissolved. Okay, let's talk about something lighter. Yeah. So now let's get back to quantum mechanics. Quantum mechanics. So what is quantum mechanics? So there is a very good introduction. So I'm gonna maybe before let me first introduce one gentleman on top left corner. Somehow, this gentleman has never, his name has never been as public, as known as everybody else. But he was considered the greatest at his time, called J.J. Thomson. He's the first one discovered their subatomic structure of atom. Before that, when the atom in Greek world is the solidest, first smallest particle. He found, well, the atom actually have a structure. Why? He found the atoms came out of sister parts flying out. That's electron. He discovered the electron. He won Nobel Prize. I guess in 1906, he won Nobel Prize in physics. Discover electron. When you discover small parts of an atom, you also discover the nucleus, right? So that's how great this gentleman is. And more importantly is, when he discovered he proposed is called the Thomson plum pudding model. If you look at the red, plum pudding, electron is stacked on the surface of these atoms. Very important. He was the greatest scientist in the world at the time. Why he's so great? Because now let's look at the bottom, the Niels Bohr, the founding father of supposed quantum mechanics. He was at the time only like 21 or 21 years old. Tried to be J.J. Thomson's student. But this problem is that he was not impressive enough being selected. So where he ended up? He ended up working for his student. That's Ernest Rutherford. Ernest Rutherford is the student of J.J. Thomson. And Niels Bohr was a student of Ernest Rutherford. 3-generation physicists, they all win Nobel Prize. For what reason? Ernest Rutherford said, my advisor was incorrect. He said he did this famous gold foil test, find out not only atom has internal structure, and atom actually nucleus size is so small size, and the electrons, and actually fly at an empty space based on this goldfish test. Okay, but the problem is when he shrink, if you look at his model, right beneath this red plum pudding model, he shrink the size of the nucleus to almost minimum size, almost 99.99%, smaller than that one. So what happens? There is no support for electrons. So his electron has a problem now. His electrons are floating around. How could that happen? The entire physics think about it, this is crazy, right? So then his student, so that's called Niels Bohr, said, okay, I can fix this one. And he fixed it. He said, well, there's a magic force. He said, I made an assertion, all these electrons cannot be anywhere, cannot be floating around. It can only circulate at a certain orbit. Cannot go in between, cannot be anywhere, only at a certain orbit, and always traveling at the speed of light. In order to floating around, you will impact, you have to traveling, right? Just like an Earth circling around the sun. If not traveling, you will have a disaster, right? So he said, well, so that's why it's so controversial. So let me show this video.
For example, the kind of light that glowed from gases when they were heated in a glass tube. When scientists observed this light through a prism, they saw something they'd never expected.
If you heated up some gas and looked at it through a prism, it formed lines. Not the continuous spectrum that you see projected by a piece of cut glass on your table, but very distinct lines.
It wouldn't give out a smear, kind of complete rainbow of light. It would give out sort of pencil beams of light at very specific colors.
And it was something of a mystery how to understand what was going on.
An explanation for the mysterious lines of color would come from a band of radical scientists who at the beginning of the 20th century were grappling with the fundamental nature of the physical world. And some of the most startling insights came from the mind of Niels Bohr, a physicist who loved to discuss new ideas over ping pong. Bohr was convinced that the solution to the mystery lay at the heart of matter, in the structure of the atom. He thought that atoms resembled tiny solar systems, with even tinier particles called electrons orbiting around a nucleus, much the way the planets orbit around the sun. But Bohr proposed that unlike the solar system, electrons could not move in just any orbit. Instead, only certain orbits were allowed.
And he had a really surprising and completely counter-physical idea, which was that there were definite states, fixed orbits that these electrons could have, and only those orbits.
Bohr said that when an atom was heated, its electrons would become agitated and leap from one fixed orbit to another. Each downward leap would emit energy in the form of light in very specific wavelengths, and that's why atoms produce very specific colors. This is where we get the phrase quantum leap.
If it weren't for the quantum leap, you would have this smear of color coming out from an atom as it got excited or de-excited. But that's not what we see in the laboratory. You see very sharp reds and very sharp greens. It's the quantum leap that's the origin and the author of that sharp color.
What made the quantum leap so surprising was that the electron goes directly from here to there, seemingly without moving through the space in between. It was as if Mars suddenly popped from its own orbit out to Jupiter. Bohr argued that the quantum leap arises from a fundamental and fundamentally weird property of electrons and atoms, that their energy comes in discrete chunks that cannot be subdivided, specific minimum quantities called quanta. And that's why there are only discrete, specific orbits that electrons can occupy.
An electron had to be here or there and simply nowhere in between. And that's like nothing we experience in everyday life.
Think of your daily life. When you eat food, you think your food is quantized? Do you think that you have to take a certain amount of minimum food? Food is not quantized. But the energy of electrons in an atom are quantized. That is very mysterious, why that is.
Okay, so I guess you all understand why, what is called quantum mechanics, why quantum mechanics comes from, right? So now I said, with this kind of theory, why even being accepted in the first place, right? You know, people are intelligent. You know, why it being accepted? Two reasons. One is this called a spectrum, so hydrogen atomic spectrum. Remember they mentioned about the quantum mechanics developer is based on the experimental data. They find, you know, every element has its own distinct, you know, spectrum, different distinct line. So they said that because of the distinct line is always a constant distance. The distance is always fixed distance. So that's why they come out with this called energy level, quantum orbits, or quantum principal quantum energy level. Because based on the test line. You know, physics started with first have a test observation, and what is guessing, what kind of propose some kind of theory, and then verify, right? So now let's see what kind of theory to justify their measurement that being accepted. They are use atomic energy structure. That's the Bohr's model. They said the different lines, distinct lines on top of the other one is because of one electron jumping through different orbits. And so how electron can jumping from orbits? They said, it has to gain energy or losing energy. But they said that if you can losing energy, anything can slow down, we're changing orbits arbitrarily, right? If you gradually losing, it says, no, you cannot gradually change it. You can only change it in a certain amount. So that's called quantum. So they have this kind of concept called massless particle, called the photon. Photon deliver a chunk of energy, just fixed chunk of energy, so electron absorb the energy, and can jump to higher orbit, or losing same amount of energy jump to lower orbit. So use one particle justify entire spectrum. This is mathematical called a window. Okay. So this is the first thing. The second thing is about the double slit experiment. I will explain this one. So there is a double slit experiment. I guess everybody know what it is. I have another video, so I'm not going to play it right here. I only have 40 minutes to go, so I'm going to speed up a little bit. Okay. This is a double slit experiment results, and so what I try to say here. So with 100 years of work for this quantum mechanics, right? We are in the introduction to quantum mechanics. So what quantum mechanics has achieved is this called a standard particle and interaction model table. This table is just equivalent to like a periodic table, summarize all the quantum particles. I know the word is so small. This is not intended for you to read. So let me summarize in a different page. In a different page, this is a great achievement in quantum mechanics called a standard model. Quantum mechanics has different branches, lot of different theory, eventually end up agreement in the standard model. Basically, it says it created so many particles. Let me give you another way to view this one. Basically, it summarizes quantum mechanics has 12 particles becomes. But however, 12 particles, and but for each particle has what is called mass, matter and antimatter. For each particle has a matter and antimatter. Have charges, anti-charges, and has spins, anti-spins, by combination. So it's a great achievement by, it's reduced from hundreds of particles. Every year they increase so many particles. Reduced to 12, sounds like a great, right? But however, if you add all these properties together, it end up with 226 combination particles. Because each particle has if a particle same mass, however different spin or different charge, will become a different elementary particle. So elementary particle has 226 elementary particle. This is the simplest one. So, and include this Gauss particle. Gauss particle is the last piece of an entire standard model we achieved. Okay, so then what kind of results we got? This is the one the page I got it is after Gauss particle was awarded. If you read this whole page, this little box I zoomed out. If you read here, called currently standard model is incomplete and does not explain many important features of a known universe, such as gravity, mass, dark matter, dark energy. We basically get to ground one. This has been problem over almost 100 years. We have not solved one thing. Okay, people may say, well, Gauss particle created this by solving mass problem. Now let's see what it really solved. If you look at the top here, the Higgs boson discovered in 2012 provided an explanation for how the other particle get mass. Still doesn't explain where the Gauss particle get mass. Solve nothing. That's what modern physics most fear about. He said, we suppose completed our entire theory, we still solve nothing. What that means? entire theory fundamentally flawed. So where is the flaw? Here, I summarized all unsolved mystery in the world, in the universe. Besides, if you look at the numbers 3, 4, 5, 6, that's a gravity, mass, dark matter, dark energy. So I add two. One is the nature of light. That's the confusion. I first said that's the first confusion. It's called wave-particle duality. The second one is electric charge. So what is electric charge? I'm going to review this one. Now comes to theory of everything. So just for your understanding.
The search for a single fundamental particle is matched by the search for a single force that governs the behavior of everything. This was Albert Einstein's great quest for the last 25 years of his life. More than once, he thought he had done it, only to learn his solution was fatally flawed. When Einstein was working on unification, he recognized two forces, gravity and electromagnetism. But today, physicists have to deal with two others, the strong force and the weak force.
The weak force is responsible for many forms of radioactivity. The strong force holds our nucleus together. The nucleus is full of protons, which all have positive charges. And if there was nothing to hold them together, the electric forces would make them fly apart, because equal charges are repelled. The strong force prevents that from happening.
The more you learn about nature, the simpler it looks. And that's why I think we will find a final theory. Because although I can imagine things getting infinitely more complicated, complication without end, I can't imagine simplicity without end. The whole progress of physics has been toward a more and more simple description of nature. And how simple can things get? Simplicity must finally terminate. There must be something so simple that we can't imagine anything more simple.
I think it's almost a religious belief that things must somehow very deep down be simple, and that we are to some degree blind and don't see this simplicity but are searching for it. Now that's what physics has been doing always. Very difficult processes, very difficult phenomenon which seemingly are unrelated, chaotic, through simple descriptions, pull them together and unify them. And that will go on for a long, long time.
This is some, before I reveal what it is, the fundamental principle, unification of theory of everything. I just summarize all the properties one particle has to have in order for this world to work. One is have a mass, another have a volume. Volume has been missing in entire particle physics. They assuming particle has no size, is point particles. So they never mentioned about where the size of it goes, right? And also has to have a charge, electric charge, right? The charge was born. It's natural, and the gravity and the four forces. These are four forces, the field forces. Okay. Here we go. Entire universe built by one called the universal fundamental magnetic particle, just a little magnet. We mentioned about light was transmitted by little magnets, right? Magnetic particles. So now, what I need to approve? So this particle can also transmit what is that? Gravity. Am I right? Strong force and then weak force. Number one, that's smart. Josh mentioned that when I first discussed one, he mentioned this magnet. This is something we know, right? I said, yes. That's the premise of all the assumptions I have. I believe the true law of physics should be intuitive to us, not strange to us. if fundamental build of the particles, it has to be known by everybody, have to be used by everybody. It's not be a strange, just little magnet. I call it called the universal fundamental magnetic particle. I put it as ions, okay, just like ions, electrons, okay? And so what it does, so let me complete this theory first. So the theory called the axiom of the universe. Just one principle, one particle, one principle. So that all matter is made up of universal fundamental magnetic particles, ions, that has a mass, magnetic fields, and occupy space. This is only differ by the standard definition of matter. One thing, standard definition without a magnetic field. So that's why it missed gravity. It missed all the interactions in standard matter definition. So the world is dead, is not dynamic. With these things, I'm telling you, I tested thousands of times. It works for everything with this magnetic field. Okay, so I'm going to move in faster. So first question, can you duplicate it with this magnetic particle? Can you duplicate the entire world as we know it? I first build the electrons. You look at the top electrons, when magnetic particle rotates, you look at the top versus the two bottom. The two bottom particle electrons, I copied from a Google website, Google page. There is no difference, let me tell you. The current interpretation is electric charge was born with, and the rotating electric charge created south-north pole, and the south-north pole make electrons traveling in magnetic fields. This theory tells you exactly opposite. We have magnetic field, magnets, rotating magnets, that means moving magnets, that's equivalent to electric field, equivalent to charge. I try to take electric out of the language, just moving magnets or spin magnets. That's all the electric charge is. Okay, so I know people try to find the difference. There is no difference. Let me take it. This is I use identity, plot, data, everything the same thing. So now we solve the electrons, right? Now let's solve even more positrons. Positron means spin oppositely. So now we say we can create a positron, no problem. And then another one is neutrinos. Neutrino is a neutral particle. We know most matter does not have charge. So how can you create the neutrinos? You see how easy to create the neutrinos. You have two magnets, opposite, stick together. Then you look at every single, so they have a spherical magnetic field. It will be neutral to any matter, at a distance. So this neutrino created by the same magnet, I do believe this is true. Okay, so why I'm presenting? Because I have confirmed this is, the real world is just as simple. Okay, so now we create a neutrino. So how to create this proton? Proton is very simple. The current theory says nucleus is what is 99% of the weight, right? Weight heavier than electrons. Size-wise, they both are the same size. In my theory, they all based on the same particle. They all have size. The entire nucleus is just the size of the atom size. But it has to follow certain law because the opposite charge, opposite pole attracts, same pole repels. When you program this one, you got a proton, you got a neutron, you got a anti-proton. So basically, these are all fundamental building blocks. So from there, we can create the entire universe elements. So now, let me review the secret of the gravity. What is gravity? The central, Isaac Newton and Einstein, they died for finding gravity. Gravity is nothing more, just little magnetic field, the attract force of magnetic field. So now, let me explain. So basically, gravity is just a part of a magnetic field, just part of an attraction force. How do you know that one? So let me demonstrate. First one uses the smallest particle. Magnetic particles, I call it a universal particle, ions, right? Ions, if they opposite poles on the top line, opposite poles they attract each other, and then the second line is the same poles repel, right? What happens is you put the two magnets repel each other. It rotates. See? This is a repel. What happens? If you push them together, they rotate. After rotating, then they are positive and negative, they're lined together, they attract each other. So gravity is just a resultant result of this magnetic field. When you have both repel and attraction always end up the winner. So we missed the process. Actually, the process, if you are a similar pole, you were rotated and you were attracted. So now let's look at the bottom of where. Here is a neutrino. So now neutrino is a neutral, right? Under free state, if you see neutrino still close enough, still have a positive and negative pole, it will still attract the matter together. That's how we said neutron particles. We said, wow, this is there's no electric charge, there's no magnetic force. Why they attract each other? Naturally, at free state, they will rotate, align together. That's how all the particles, surround the Earth with immersed with this invisible fluid, because we are just made by one single magnetic particle. And then, so they said, you said this one physically. What about mathematically? Do gravity related to this electromagnetic field, right? You look at the equation. Gravity equation and this magnetic field equation. If you look at force in gravity equals to 2 mass divided by identical equation. When I took this class in middle school, I said, I knew it. They must relate it somehow. I know everybody here have that word. You must realize. At that time, the equation, why they're so similar? They're only different by one constant. There's a calibration constant because it's developed by two different people. When you're two different people, you name it differently, and you quantize, calibrate it differently. So that's why constant. They are fundamentally the same thing. There's no difference. That's the ultimate secret about gravity. So there's nothing more, actually, just a part of a magnetic field. And then another one, I'm talking about how to build from atoms to build molecules. If you look at here,